Guys, Felipe here. So in this video, I'm going to basically be using the Rust programming language and specifically using the file system operations, which is pretty cool. You can basically manipulate files using Rust, which is cool. So I'm going to go ahead and jump right into that and kind of explain and show what that means or looks like, right? So first and foremost, we got to do agent cargo to create a new crate, right? So cargo new file operations or file operations. Boom, there we go. Beautiful. We're going to go into this directory that was just created. Not go into it, but we're going to cd into it, right? Boom. We're going to cd into the source that gets created. And we're going to create a file called fs.rs. Beautiful. Now we're going to go into the action here. So we're going to use a couple of packages, crates, dependencies, whatever you want to call these things. So we're going to import or use in the Rust terminology, fs, which I believe stands for file system. And we're going to use std, fs, and we're going to bring in file and open options. Beautiful. All right. And now we're going to use std io, lowercase io. And we're going to use std io prelude. And we're bringing everything from this puppy in here, right? So prelude and everything from in this puppy, right? And we're going to use a configuration conditional check, which is a CFG, targets, family, misspelled the hell out of that, family, equals, Unix. So this is basically going to check if I'm actually in a Unix system, which I'm on a Mac, which is Unix. There we go. Awesome. And we're going to bring in the stdos Unix. So we can use some Unix operating system commands, right? Beautiful. And lastly, std, path, boom. So we can work with paths. So first and foremost, we're going to create a simple implementation of cat's path. So cat, it's a command that just basically outputs whatever content the file has onto the terminal. So we're going to create that function here, function cat, takes in a path and a reference to path, and it returns IO results of type string. Sweet. Result is an enum. It has two variants. What that means is it can either be one thing or the other. It can't be both. One of the variants is okay, and one of the variants is error. So it can't be both. It can only be okay or it can be error. We're going to do a create a mutf variable, which is a mutable variable, right? By default, variables in Rust are immutable, so you have to declare the mute there to make it mutable, right? So we're going to open path right here, sweet, and we're going to use the question mark. Question mark is like unwrap, where basically it'll return the error instead of panicking, which panicking is no bueno. It crashes your program. So you don't want that to happen. And we're going to use a string new. So let mute s equals a new string. So creating a new empty string there. And we're going to use a match read to string. And we're going to pass in that mutable string, which is in the s variable that we just created. Keep in mind that this is a result type, right? There's a variance, so the arms are going to be, the match arms are going to either be okay, and if it's okay, give me that string, right? And if it's not okay, it's going to be an error, right? And if it's an error, give me that error. right? So it's a variance of 2. It's either okay or it's either error. All right, beautiful. So now we're going to do a simple implementation of echo path. So we're going to echo something into a file, right? That's basically what the echo command does on operating systems. So echo is going to take in a string, not a string, a stir, and it's going to take in a path, reference to path, and it's going to return a result of unit type, which I'm not using the right syntax there, unit type. Awesome, there we go. So let mutable f equal file with a capital F, not a lowercase f, file creates path. So we're using the file from the fs crate, and we're using a method called create from that crate to create the path, right? And then we're going to throw in a question mark there, kind of like the dot on wrap. So in case it returns an error, give us the as an error handler instead of it just blows up with a panic, right? So writes all s.s bytes and no semicolon here, because otherwise this function wouldn't work. Perfect. So we have an echo and a cat function so far, which basically mimics or does what the actual echo and cat commands do on the terminal on any operating system. Let's create a simple implementation of the touch path. Ignores existing files. So we're going to create basically the touch command here, right, which creates files, right? Touch. It's going to take in a path and reference to path, right? And it's going to be an IO result of unit type, which basically means it has no return, right? So in here, we're going to use a match and open options, new, dot creates is true, dot writes is true, dot open path. Sweet, there we go. This is it's the results. It's either going to be a variance, which is going to match one of these arms in the match, right? Of okay. Or is going to be an error, right? And if it's an error, give me that error. Give me that error. Okay. Moving along. Moving along. All right. So that's touch right there. Nice. And now we're going to use a match, a main. We're going to create a main function, which is the entry point to Rust programs, basically. Is what gets called when you run a Rust file is the main function, which basically runs everything else. And we're going to use the println macro. You can tell whether it's a macro or not, because typically it ends with a exclamation mark. And all I'm going to do here is echo hello a/b.txt. So I'm basically just logging onto the terminal through the println macro, what command I'm actually going to, what function I'm actually going to run beforehand, right? Or after the println, right? So first and foremost, going to create a directory that returns an IO of results of unit type. Beautiful. And that's gonna be a match fs. So we're actually using the fs creator method here. And we're gonna create a directory called A. And since it's a result, right, it's either gonna be the error or and if it is the error, right, we're gonna print pretty prints the error and the kind of error. Sweet. So if it's not the error, it's gonna be okay. And if it matches this arm, it's okay. All right, great. So moving along here, println, boom, boom, boom. And here, actually, I'm gonna do the make there because I'm just gonna swap these because I used that above. So make there A. Beautiful. Close that off. Boom, boom. What am I doing? I have no idea. All right, so I'm just gonna remove that from here and put it here. Remove that from here and put it here. And now we're gonna call the echo command here. Echo. Hello. So we're actually using the echo command from above. We're passing in a reference to path. Hello. We're gonna hello here, right? We're gonna pass in the reference to the path. New a forward slash dot b dot txt, and we're gonna use dots unwrap or else. So either work or else, and we're gonna capture the error right here. Beautiful. And we're gonna print the error in the case that there's an error, right? So println, pretty print, boom, 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 and y kinds for the type of error. Nice. So that's basically echo in action right there. Now we're gonna do a println, boom, boom. Make dir dash p a forward slash c forward slash d. So we're gonna make all these directories using this existing command. So recursive delete creates a directory that returns IO results of unit type. And we're going to use the existing create directory, create dir all. So create dir all, create all directories from the fs crate. And we're going to create a forward slash a is created. So we're going to create c forward slash d and then we're going to use our good old friend unwrap or else. So it works or error. Capture the error in here in the closure. And then if it is the error, we're going to print alone. Pretty prints the error. And then usual y.kinds for the type or kind of error that we're getting, right? There we go, boom, boom, boom. Close that off there. And now println. We're going to use touch. So we're going to use touch below here. a/c/e.txt. So we're going to create an e.txt file inside of the C directory as inside of the A directory. So we're going to use the touch command we created above, pass in the path, the reference to path, new a/a/c/e.txt, use the unwrap or else, capture the error in a closure, print error, println error. All right, pretty print, boom, 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 y.kind for the kind of error, and close this puppy up. There we go. Must have some, oh yeah, semicolon. That was the problem there. All right, so now println, boom, boom, boom. We're gonna do a symlink from the dots /b.txt to a/c/b.txt. So we're creating a symbolic link here. That's what we're doing. So creates a symbolic link, returns IO results, unit type. Sweet. So now here we're going to use another configuration conditional check. So that's a CFG target family equals, is this Unix, right? It's Unix, that's basically the condition there. Why? Because we're going to utilize a Unix operating system command specifically. So Unix fs symlink is if you were using Windows or something along those lines, it would be different. So dots / e.txt, close it off right there. A /c /b.txt. Beautiful. Boom. Use the unwrap or else. Capture the error in a closure. Println the error in a pretty format. Boom, 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 boom. And y.kind to give us the type of error, right? All right, sweet. And now we're just going to close off that conditional check right there. So basically, we're utilizing a Unix operating system commands if that conditional is true. All right, moving along, println. What we're going to do here, we're going to utilize the cat command we created above for b.txt. Beautiful. So we're just going to match cats reference path new a/a/b.txt. All right. And since it is a result, right, it's going to be either error. If it is error, if it matches this arm, println, pretty prints that error and what that error is, y.kind, right? And if it's not an error, give us the string, println, macro, with this forward arrow here to point to the string, right, that we're printing out. Close this bad boy up. Now we're going to do a println ls-a, so list all. So we're going to read the contents of a directory, and this returns an IO results of type vec path. So it's a vector with paths inside. The vector is basically a data structure of unknown size, so it can grow, right? It can continue to grow depending on what's in there or what things are put in there. And it's usually stored on the hash, not on the stack. So that's what that is. Then we're going to do a match fs read dir, which is an fs creates a method, and we want to list anything that's inside of the A directory out to the standard output, right? So it's a variant, so it's either going to be error, and if it is an error, we're going to print the error in a pretty format. And y.kind for the kind of error. If it's okay, we want the paths, and we're going to run a for loop, for loop here, path in to get each individual path from the paths, right, in the vector. And we're going to print them, boom, boom, boom. So print ln macro over here with this forward arrow pointing to the preprint formats path that we're printing out, or thing that we're printing out from the A directory, right? All the stuff in there inside of the A directory. Then we're going to do a path dot unwrap in case this all blows up, just because it's the error, instead of panicking and blowing up. And closes off. All right, here we go. All right, let's print ln rm. So we're removing a/c/e.txt. So we're removing e.txt that's inside of the C directory, that's inside of the A directory. So remove file, and this returns IO results unit type. So fs remove file, it already has a method for that, right? Which is beautiful. a/c/e.txt is going to get deleted. And then we're going to use a good buddy unwrap or else, capture the error, closure, print ln, pre-print the error, and kind of error. Close this bad boy up. And we're going to do a print ln, remove the directory, a/c/d. We're removing d. So we're remove n m. That's my little comment there. Remove an empty directory returns IO results of unit type, and we're going to use the existing method remove dir from the fs crates. So remove dir, so remove the directory from a/c/d. So we're giving it the path there, and then we're going to do our unwrap or else and capture the error and a closure, and then print ln pretty prints. This little exclamation over here, pretty prints. Y.kind for kind of error, Close this bad boy up. And save it. See if anything is crying. Yeah, missing a semicolon here. Syntax error, expected semicolon. That's a dot. That is a dot. That is a semicolon. Okay, what else is it crying about? Is it crying about anything else? Looks good to me so far. The only way to find out, really, is by running this thing. Right. So we're going to use the Rust compiler, which is Rust C, and we're going to run fs.rs and create a binary right there. Boom. So it blew up on me. What is going on? Unused import. So that means I'm going to spell this over here. Mismatch type. What is this crying about? And that's line 30. All right, so I'll start with that one, 28 and 30. All right, let's go back in here. 28 and 30. Syntax error, expected a fat arrow. Of course. I missed the fat arrow. Can't miss the fat arrow. Where's 30? Was that 30? Okay, so this is the other error. I misspelled this over here. Okay, move. Should work now. Nope. Okay, expected. Where is this 30? Mismatch types. All right, what is this? 30J. This is the touch touch command. So what is going on here? Oh yeah, because it's messed that up. All right, is it gonna work now? No. So why is this crying? I got it. Okay. So I have to, it's because I'm not passing in. No, it's not it. The error. Oh, of course. Blind, apparently. And if we run this now, it should spit up all those commands on the terminal, right? So basically, we made a directory A, we echoed hello and created b.txt because it doesn't exist. We recursively created these files here. We touched e.txt inside of the C directory. We created a symbolic link right here. We cat b.txt, which had hello in it. We listed and then we removed some files and directories right there. Great, so that worked. Now if I do a tree A, we can kind of see all that action in the tree, right? Beautiful. Cool. So that is basically the file operations methods that Rust has. It's pretty cool. You can basically create commands and utilize existing methods to manipulate file systems using Rust, which is pretty cool. So that's about it. If you guys liked the video and learned something as I did, feel free to like and subscribe. I'll talk to you guys on the next one.